Hi, my name is Dan Low. In this video, I'm going to show you how to write a Python program to predict COVID-19 death toll tomorrow, for example. Okay, and I'm going to use a TensorFlow and also Google Colab. Okay, so after this tutorial, you should be able to load COVID-19 data from GitHub provided by John Hopkins University, and you'll be able to use the TensorFlow in Google Colab to predict death tolls by country. For example, in your country, you want to see what's the death toll today or tomorrow. And this is just for programming exercise, in machine learning only. I don't infer anything. Okay, and also the value predicted here is just for your reference only. And again, please wear masks to protect yourself and others when you go out. Okay, so let's first test this. Just print something now to see if system's working. So you can shift to enter, and now it print out my name, so it works very good. Okay, now first thing we're gonna load the data set from GitHub directly. So normally this type of daily change your data set, you don't want to download it to your computer and then upload it to the programming platform you're using, because then you need to again download the data every day, and you don't want to do that. So download the dataset directly from the GitHub will actually give you a lot of benefits, advantages. First, you don't need to load it every day. Second, you will save your hard drive space. Okay, so first thing, we're gonna use the pandas package, to read the data or load the data directly from the GitHub to the Google Colab, and nothing is going down to your local hard drive, and you can run this program by clicking the links I share with you at the description of this video. So we can read the CSV file, the dataset. The dataset I use is the accumulated or death tolls internationally. Okay, so you can run this program, and now we're supposed to read the data to the data frame. Okay, df. So after that, we can run the df.head this statement will list the 5 rows of the data. Okay, so the data look like this. You got 124 columns. Okay, the first column province or state, and second the country region, and then latitude, longitude of the country, and then starting from the January 22nd, you got this total, and this data is accumulated. Okay, accumulated. So you can see that is 18, 18, 21, 23, 25. So it's accumulated. So that's one thing you need to understand. Second is the province and state. We probably don't need that. We only need the country. So we need to delete some of the columns. Latitude, longitude, we don't need that. So we're gonna drop those 3 columns by using the drop method provided by pandas. So you can say drop columns equal to the list in your province, state, and the latitude, longitude. So these 3 columns will be dropped. So you can run this. Go ahead, run this. And as you can see that now the 3 columns got removed. We only got the columns we need. Okay. So you got 3 columns removed. So you can now 121 columns. Okay. So next is we're gonna group by the country, because notice that the United States have 52 states. Therefore, you might have 52 rows that represent United States. So you need to group them together. So group by is the function provide that kind of computation. So you can group by the country, region, and sum them together. So you're gonna have this, run it, and the next is if you print to predict the trends of your country, you need to find your country name here. So here I simply use a for loop, to print out all the country name there. And before you do that, I do a transpose. So this T means transpose, because we now have the each row represent the country, but in the plot or analysis, or algorithm, we need the uh, column major, or the data sitting in the column. So we do a transpose. Transpose means we exchange the rows and columns, and after that, all the column headings will become the country names. So gonna run this one. So go ahead, find your country name here, and remember that, for example, the one that has two letters with space, like New Zealand, for example, here New Zealand, you have to have space in between, exactly like uppercase N and uppercase Z. Otherwise, the program will not work. So go ahead, find your country name. And the next thing is we're gonna slice the US data only, because I'm gonna use the US data as an example. So just put the US in the quotation single quote mark here. You can change the US to your country name, but remain the single quote there. Okay, that will slice out the US data. Okay, so after that, I'm gonna run the plot, white dot plot, where plot the data. So this is the US data desktop, accumulated. So the trend is going up like this. Okay, and but since we are going to predict daily toll, okay, therefore we need to compute the daily change. So daily change is computed by today's accumulated desktop minus yesterday. Okay, and that'll be today's increment. So we can use a for loop and go reverse order from the y series. Okay, and then go backwards, and we can do this subtraction. Okay, and we can do that, then we can plot it again. So that will be the daily change. Look at like a stock market. Okay, so it changes up and down. So our goal is to use a TensorFlow to find a function, a curve that will fit into this. Okay, so at this point we got the data ready. So and we also have to do some data pre-processing, and in data science it's called the data engineering. So we need to prepare the training data. So here the training data, we have the y, the daily change desktop, okay, already there, but we also need to normalize it. So let's start with the x. X now is the dates starting from the January 22nd all the way to yesterday, which is May 20th. Then we need to actually convert this into numbers. Okay, so the easiest way is what I do here. Just do the 0, 1, 2, 3 all the way to whatever the last one is. So we do the index. So we create a list of numbers from 0 to the latest index. After that, we normalize to the size, so make sure that the value is within the range of 0 and 1. Okay, so go ahead and run it. So now we have the X training data prepared, and we're gonna do the same thing for the Y. Y is the daily desktop. We extracted from the data set, and we need to normalize it. So the easy way to normalize is you gonna divide by the maximum value plus 1. So make sure that again the y's value is within 0 and 1. So you go ahead and run it. So after that, we gonna have the x training data and y training data ready for the machine learning to learn. Okay, so it's time to get the TensorFlow library in and then create a model. So this import statement will import the TensorFlow library. Okay, and with the TF reference to the TensorFlow object, and then we're gonna create a model. Okay, using the TF that keras the models, that sequential. Okay, and here we're gonna create the TensorFlow with the two hidden layers. And the first hidden layer has 64 neurons. The second one has 128. And elevation function, I use the ReLU. ReLU is basically a sigmoid function, but the negative values will be replaced with zero. From some study, the ReLU is very good, very efficient. And the input share is one dimension. Okay, so after that, I have the model defined. Now I'm gonna run the model.summary to take a look at the summary of the model I've just defined or created. So this shows the model I've just created. So as you can see, there are 64 neurons here and 128 neurons the second layer, and then total parameters is 8,577, and these numbers will be trained later. So in order to train the data, we need to compile or configure your a model by setting some hyperparameters. So for example, optimizer, I set it to Adam. Adam is a pretty good optimizer. And the loss function, how close to the predicted curve, okay, against to the actual curve with the mean square errors. And the metrics, I use also MAE and MSE, to determine when the training is done is good. Okay, so go ahead, run it, and after that, your model is ready for training. So provide the training data x and y, and we set epoch equal to 500, 500 iteration during training. Also, we keep a history here that will collect the information during the training. So this training depends on where you actually we are running on the Google Cloud, so it should be very fast. Okay, so now I got about 390, 400. Okay, you can see that the errors are getting smaller and smaller, and that's a good sign. And now we got done. So after that, we got a history on data, which actually the information gathered during the training. So we can go ahead to see some of the information we collected, like error, mean or absolute errors. So this is the first 5 rows, okay, of this. So and we can also plot it, okay. So you can go ahead, hit stop plot, or see the error. Okay, so the error in the beginning is very high, and then eventually go down. So that's a good sign. Okay, and the next what we're going to do, we're going to predict, since we have model trained. Okay, so as you remember that we normalize the x into 0 and 1. So when the x value is 1, it's actually today. Okay, today's x value. So we go ahead and put the x equal to 1.0 and run the model to predict the value. And this will give you today's death toll. Okay, and we go ahead and print it out, and you see the number is 1,328. You can check this number to the actual number reported today, but it's not that up yet. But again, this is just for your reference. This will be the predicted death toll today in which is the May 21st for the United States. It's not up yet, but this is from our prediction. So it's quite severe. This COVID-19 coronavirus is spreading everywhere, and so pay a lot of attention to elders in your family. This could be disaster. Okay, and the next thing we can actually see how good this model is by plot all the predicted values from all the X train. So all the the values we train, okay, we can actually predict again, and so we have the predicted value versus the actual value. So this is give you the idea about how your model perform. And so now we have all the predicted values here. And the predicted value is actually a list of lists. Okay, so I can then convert it to pandas series. Okay, put it into YP. So you have plot Y, which is the original data, and then also the predicted data YP the plot together. You can see the two curves together. So I can see that the blue line here is the original data. Okay, the daily change, and then orange line is the learned a curve we have. So if you go ahead want to print just print plot the curve, and this is the curve learned from it. So you can see that the trend is going down as of today, May 21st. The day starting going down, which is good sign. Okay, but we don't know, when we will come back. So by the time you run this program, it may have different shape. Okay, so anyway, this is a very brief program, to do prediction desktop of COVID-19 using TensorFlow, and hope you know learn something. So if you like it, please subscribe and or share or give a comment. Thank you.